Hello there. Yes, man. Welcome to CXC Math TV. Today we will be looking at the different types of numbers. Alright, so for the different types of numbers, let's first establish our objectives. The objectives are we want to look at factors, prime numbers, composite numbers, odd numbers, and even numbers. These are the different types of numbers. So the first thing, of course, a factor. What is a factor? Now this word a factor is just a number that when it is multiplied by another, it gives a product. Alright? So for example, 7 times 8 equals 56. We had to multiply 7 by 8 to give us 56. In other words, we're saying then that the factors are 7 and 8. Because when you multiply 7 times 8, it gave us the product of 56. In other words, we're concluding that a factor of 56, this is what we're saying, a factor of 56 is 7. Or we're also saying a factor of 56 is 8. Hey! Alright, that's what we're saying. Now maybe you don't like that technical definition of what a factor is. That's also fine. We can define a factor as a number that divides evenly into another number. So that same number 56, look at it. When you divide 56 by 8, can 8 be divided evenly into 56? Yes. When you divide 56 by 8, you get 7. So in that case now, because we see that 8 can be divided evenly into 56, giving us a quotient of 7 and no remainder, in that case we say that 56 has a factor of 8. Alright, so the factors are again 8 and 7. Now, how did I know that 7 is a factor? By this definition. Alright, I know it's not displayed, but look at it. If you were to then divide 56 by 7, what would you get? Of course, 8. When you divide 56 by 7, you get 8. So realize 7 can also be evenly divided into 56, giving us a quotient of 8. In other words, we're saying that factors of 56 are, again, 7 and 8. Okay. Let's try some questions together. Look at this right here. Again, as can be seen on the screen, 6 times 7 is 42, right? And so clearly, what are we saying? What are we saying then? Tell me. We're saying then that the factors of the product 42 is 6 and 7. Now, if we say 63 divided by 9 equals 7, what are we saying? Then we're saying the factors of 63 is 7 and 9. And the product is, of course, 63. And again, if we see 8 times 5, what are we saying? We're then saying that the factors are 8 and 5. And the product is 40. That's it. That's all we're saying. So again, remember, there's 2 ways you can define factors, okay? Alright, so now here are some questions to try. We'll do the first one together and then you do number 2 and number 3 on your own. So the first one, it says list the factors of the number 78. So let's do the first one. So the first thing is 78. I know that 78 is what? I can say 78 is 1 times 78. Isn't that so? I can say that 78 is 1 times 78. 1 times any number, give us back that number. Magical. So in that case now, what we're then saying is that these numbers, remember, the product, right? The 2 numbers that we multiply to get the product, these are factors. So already we get 2 factors already. So we get 2 factors of 78 is 1 and 78. Let's find out some more. Again, 78. Can't we say 78 is 2 times 39? Yeah. 78 is 2 times 39. So again, two more factors are 2 and 39. Let's keep it going. Let's keep it going. Now, 78. Can we break up? Can 3 be divided into 78? No, there's a quick way to determine if 3 can be divided into 78. Now, don't worry, we're going to make a video on that. Alright, whenever you have a number, if you add the two digits of that number, so when you add 7 and 8, you get 15. Now what we're saying is if 3 can go into that added number, yes, 15 divided by 3 is 5. Then in that case, 3 can also go into 78. Let me say it again. To determine if 3 can be divided into 78, what we then do is we add the two numbers, and then if 3 can go into that added number, then 3 can also go into 78. Cool, so since we now figured out that 3 can go into 78, we'll go, okay. So now it's 3 times what would give us 78. So we do the division, 78 divided by 3, 3 into 7, 2 times, remainder is 1, and then 3 into 18 goes 6 times, so it's 3 times 26. Now I know some of you would have been able to look at it and tell straight away, no problem. We're just going slow, okay? Sometimes it's best to go as slow as possible to not make any mistakes. Let's continue. Now, can we break it up any other way? Can we put 4 into 78? Absolutely not. Alright, 4 cannot go into 78. Can 5 go into 78? Absolutely not. Can 6 go into 78? Now, let's check it. Chances are if 3 can go into 78, then 6 should be able to go into 78, don't it? So look at it. 78, if you divide it by 6, that would give us 13. And so in that case now, 78 is just 6 times 13. And many of you should have known this because 6 12 72. We know our 12 times table and our 6 times table. And so if you added one more group of 6, you'd get the 78. We should have known that easily. Alright, now can 7 go into it? Absolutely not. Can 8 go into it? Absolutely what? Absolutely not. Can 9 go into it? No. Can 10 go into it? No. Can 11 go into it? No. Can 12 go into it? No. Alright, and so what do we realize? We've gotten all the factors. Alright, we've gotten all the factors. So therefore we can list out all the factors now of 78. So list them out. So the factors of 78 are, listing them out. 1, I'm going to list them in chronological order, or more so in ascending order. I like to start from the smallest to the highest. So 1, 2, 3, 6. Look if we left out any. Nope, we didn't. So 1, 2, 3, 6. Then we say 13. Then we say 26. Then we say 39. Then we say 78. Really nice. And that's it. Those are all the factors of 78. Wow. Nice. So we did the first one together really slow. Now it's your turn. Find the factors of 120. Pause the video and find all the factors of 120. Okay, let's do it together now. So for 120, right? We already know the first two. We know 120 is 1 times 120. Easy. Now, the next one. We can always go 2 now, and we know 2 times 60 would give us 120. That's also easy, no problem. Then we go what? 3 next. That would be 3 times 40. That would also give us what? 120. So far easy. Then we go what? 4 next. And we know 4 times what? 4 times 30 gives us what? 120. So far this is easy, man. Because the number ends with 0, we know 5 can go into it as well. So we know what? 5 times what give us 120? So we know it's 24, but I'm just showing the division here. 5 into 12, 2 times. 2 5s 10. We subtract. Remainder is 2. Bring down the 0. 5 into 20 goes 4 times. So 120 is also 5 times 24. Okay? We know 6 can also go into it, right? So no problem. Because if you watch T20 cricket, we know 20 overs of 6 deliveries make up 120 balls, right? Well, let's say you didn't watch cricket, that's fine. So we're just saying 6 times 20 is also what? 120. We definitely know 7 cannot go into it. Definitely not. Alright? So we don't even need to try 7. No, you can try 7 and you're going to get a remainder. Alright? So I'm just doing it here so you can look and follow. 7 into 12, 1 time. 7 times 1, 7. Subtract, remainder 5. Bring down the 0. 7 into 50 goes 7 times. 7 sevens 49. But guess what? Remainder is 1. We don't have a 0 down here, so we cannot stop, right? So since we cannot stop, then therefore 7 cannot evenly divide it into 120. Next we go with 8. Can 8 work? Well, chances are 4 did, 8 should work. So 8 is going to be 8 times 15. Alright, that will give us 120. Cool. Really nice. So I know you're probably running out of breath and you're getting a little tired now. You're like, man, I'm doing so much work here. No problem. Let's continue. Now, let's go with 9. Alright, so 120. We do our division. 9 into 12, 1 time. 9 times 1, 9. We subtract. 12 minus 9 is 3. Bring down the 0. But 9 into 30 goes 3 times. But we're going to get some remainders. So 9 doesn't work. Doesn't work at all. So in that case, we go to 10. 10 definitely works. That's just 10 times 12. Nice. Okay. We're definitely not going to try 11. Right? That's obvious that we're not going to try 11. 11 won't go into 120. We won't try 12 because here's 12. We already know 12 will go into 120. So therefore, we found all the factors. You're wondering, how do you know when to stop? Right? You're probably saying, why don't we do this now and then say it's now 12 times 10? No, because we've already listed 10 and 12 as 2 factors. So you don't need to reverse the order. Because we know that multiplication is commutative. So we already, once we get to the last factor, we went in ascending order. We don't need to flip the order and then say keep on going. 12 times 10. And then say 15 times 8. We don't need to write out all of those, alright? So we can stop it right here. So now we can tell them that the factors of 120 are, let's list them out. 1, 2, 3, 4, 5, 6, 8, 10, 12. I don't even have enough space. 15, 20, 24, 30, 40, and 60, and 120. Those are all the factors of 120. Really nice. Alright, the third and final one. Finish strong for me. Go ahead, pause the video and list all the factors of the number 55. Alright, so let's do that one. So, as you have paused the video and list all the factors again, you start by saying 55 is 1 times 55, right? Good. Now, we definitely know 2 and 3 cannot go into 55, right? Because, well, just looking at the number, right, you'd say 2 doesn't look like it can go into it. 3, when you add 5 and 5, you get 10. So, 10 is not divisible by 3. And so, 4 won't work. And so again, let's try 5. Alright? So let's try 5 now. Now definitely 5 will work. Right? 5 11s give us 55. We would have learned that from our 5 times table, right? Easy stuff. Now after we do that now, 6 won't work, 7 won't work, 8 won't work, 9 won't work, 10 won't work. Now, many of you probably want to know, how do you know which number will work? There are many shortcuts to know when a number is divisible by another number. How do you know when it's divisible by 2? When is it divisible by 3? When is it divisible by 4? When is it divisible by 5? Another video is coming that will tell you how to know if it is divisible by 2, 3, 4, 5, 6, 7, 8, or 9, or 10, okay? The video is coming on that very soon. But in that case, we'd stop right here. And so we can list that the factors of 55 are, just listing them out, 1, 5, 11, and 55. Really nice. Now, we spent majority of this video on factors, and why did we do that? Because now we're going to get into the types of numbers. Finally, we can start the topic for today. So the first one is a prime number. What is a prime number? A prime number is just a number that has only two factors, itself and 1, meaning no other number cannot be divided evenly into it. Alright, so for example, the number 7. 7 is a prime number because the only numbers that can divide evenly into it are 1 and 7. Think about it, try it. So 7 divided by 2, you're going to get 3, but with a remainder of 1 over 2. 7 divided by 3, you're going to get what? 2, and remainder what? 1 over 3. Still get a remainder. 7 divided by 4, you're going to get what? 1 with a remainder of 3 over 4. And so on. The only two numbers that can be divided into 7 is what? 7 divided by 1 and what? 7 divided by 7. Ah, nice. Yeah, man. So examples of prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, and the list goes on. These are all the prime numbers listed down here below, less than 40. All prime numbers, less than 40. Nice. Okay, the next type of number is composite number. Now, a composite number is just not a prime number. So a number that has two or more factors. So, for example, the number 8, right? 8 has 4 factors, 1, 2, 4, and 8. Now, I didn't show you the working because you know how to get all the factors of 8. Remember, we just did it. You'd say 8 is 1 times 8, and you'd say 8 is also 2 times 4. So all the factors of 8 then would just be 1, 2, 4, and 8. So we know that, right? So some examples of composite numbers are shown below: 4, 6, 8, 9, 10, 12, 14, 15, 16, 18, 20, 21, and so forth. Now, again, remember, composite number, 2 or more factors. Prime numbers, only 2 factors. So here's a special thing to note. 1 is very special. I'm going to ask you this question. Do you think 1 is a prime number? Or do you think 1 is a composite number? What are your thoughts? Now, 1 is special because 1 is not a prime number. Because it don't have 2 factors. It only have 1 factor, 1. And so therefore 1 is what? 1 is not composite because it doesn't have more than 2 factors. Only number can divide into 1 is 1, which is just one number. So it don't have 2 factors, so it can't be prime, right? Only itself can go into it, which is 1. And also, only one number can go into it, so it doesn't compose of 2 or more factors, so it cannot be composite. So 1 is neither prime nor composite. That's the beauty about the number 1. Wow! Nice. Okay, here are some questions for you. I want you to state if the following number is composite or prime. So the number is 67. Go ahead, pause the video. State if it's composite or prime. Alright, so again, looking at the number 67, you want to determine if it's composite or prime. So you're going to check to see if we can find any number that can go into 67. You have to try numbers less than it, right? So you realize 67 divided by 2. We already know 1 and itself will go into it. If you try divide by 2, it won't work. You're going to get a remainder. If you divide it by 3, what's going to happen? You'd get 22 and a remainder of 1 over 3. So it still don't work. If you divide it by 4, still don't work. because you're going to get what? 16 and 3 over 4. So if you divide 67 by 5, because we keep going on, still don't work. Divide 67 by 6, still don't work. Divide 67 by 7. 7 into 67 goes what? 9 times. And the remainder is what? 4 over 7. And so if we keep on going, realize that there's no number that we're going to be able to put into 67. So 67 is just equal to 1 times 67. And so the factors of 67 is what? 1 and 67. So what can we conclude? Therefore, 67 is prime. 67 is a prime number. Yay! Nice. Okay, looking at 117. Let's go. 117. Now, 117, guys. Remember I told you the shortcut to determine if it was divisible by 3. You realize that if you add 1 plus 1 plus 7, you'd get 9. Right? And 9 is divisible by 3. So clear, we realize that 117, it can be evenly divided by 3. As I said, another video is coming on that very soon, alright? So just remember, at least when you're able to check if it can be divided evenly by 3. So in that case, we realize 117 is composite. Why is it composite? Because it have more than 2 factors. Because look at it, 1 is a factor. We say that 117 is a factor and 3 is a factor. And it continues, right? So these are factors. Let me put in bracket. These are factors of 117, and so therefore clearly it have more than 2 factors. Now the third one, 93. Clearly this one is divisible by 3, right? 9 is divisible by 3, 3 is divisible by 3, so 93 must also be divisible by 3. This one is very easy. 93 is what? Composite. That was an easy one. Very easy. Wow! Now the last one, 203. So 203, I know it's a very big number, and so you're not going to keep on divide and divide and divide, right? We just need to check. Generally, you want to check with numbers 1 to 9, right? You want to check if 1 to 9 can go into 203. More so 2 to 9. Now clearly, 2 won't work, right? Because I'm sure we're all good at doing these division. 203 divided by 2, that's 101. But then we get a remainder of 1 over 2. A remainder of 1, right? So now 203, if we divide it by 3, what happens? We divide it by 3, realize that, okay, we're going to get 3 into 20 goes 6 times, remainder of 2. And then 3 into 23, that goes 7 times, remainder 2 out of 3. So not helping at all, right? So 3 can't go into it. 4 can't go into it. 5 can't go into it. 6 can't go into it. Let's try 7. 203 divided by 7, right? So now 7 into 20 goes what? 7 into 20 goes 2 times. And then the remainder is 6. And then 7 into 63 goes what? 9 times. Wow. So look, this one worked out to be fine, because realize then that 203 is actually just what? 7 times 29. Alright, so you can check it now. Just check it. 29 times 7. 9, 7, 63. Bring up 6. 7 2's 14 plus 6, 203. So automatically we have the factors of 203 are 1, 203, 7, and 29. And of course there are probably more factors, but we just wanted to get more than 2 to then be able to state that 203 is what? Composite, since it have more than 2 factors. So it is composite. Nice. Okay, the next thing to talk about is odd and even numbers. So, and even number first and then an odd number next. So if a number can be divided equally by 2, we say that the number is even. So if you can divide a number into groups of 2, it is even. And if it cannot be divided equally into groups of 2, then it is odd. For example, look at this right here. It's going to float into the screen. Let's say right here, you see we have 4 persons, right? We want to put them into groups of 2 or put them in pairs. If you have 4 persons, it's easy to put them in 2 groups of 2. So odd or even. That must be even. But look at this one here now. Look at this right here. If we have 5 persons now and we want to put them in groups of 2, realize somebody is going to be lonely, right? Somebody is going to be lonely. And so in that case now, this number here is odd. So notice 5 is odd. So it must be able to be evenly divided by 2 before we can call it even. And if it's unable to be divided by 2, it is odd. So in that case now, the quick way to remember odd and even numbers is this. If a number ends with 1, 3, 5, 7, or 9, then it is going to be an odd number. If it ends with 0, 2, 4, 6, or 8, then it is an even number. Let's do some questions so it makes sense. So it says, let's sort some numbers into odd and even. So remember the golden rule that we said previously, if it ends with 0, 2, 4, 6, or 8, even, 1, 3, 5, 7, or 9, odd. So put them in groups for me. Pause the video and attempt. Alright, so clearly many of us would say, okay, notice I use blue for odd, so let's continue with blue. This one here, odd. Put 31 there. Oh, that's not blue. End with 1, right? 53. This end with a what? 3. Odd. Once it end with, remember odd number means it end with 1, 3, 5, 7, or 9. So looking for something to end with 9 or 5. Here it is, 65. That must then be what? Odd. 127. Odd. 79. What? Odd. Nice. And then if it is not odd, then it is even. So the other numbers over here, let's put it in red. These are even. 24, 48, 92, 86, and 230. So that's it. Alright, so here it is. Nice. Let's give you one more to try to close out the day. So pause the video and attempt this one for me. Put them in their respective boxes. So this is what you should have ended up having, and that's it. Alright, really, really nice. Alright, so of course, true or false questions to close out. Alright, so let's do some more questions here. Look at this first one. So look at this first question here. It says if you add 2 even numbers together, the answer will be even. Is that true or is that false? Part A. Is that true or is that false? Pause the video, attempt it enough. If you add 2 even numbers together, the answer will be even. Okay, so look at it now. Let's check with an example. 4 plus 8. Alright, because remember, even numbers end with what? Even numbers, they end with 2, 4, 6, 8, or 0. So I'm just adding 2 even numbers. 4 and 8 is 12. But 12 ends with a what? 2, which is still even. So part A is what? True or false? True. This is true. Alright. Now part B. Part B says if you add 2 odd numbers together, the answer will be odd. True or false? So let's remember what odd numbers do, right? Odd numbers, remember they end in what? They end in 1, 3, 5, 7, right? And 9. So if you add numbers like 3 and 5, you get what? 8. But 8 is what? Even. And so therefore this is what? True or false? False. Part C. Part C says if you multiply 2 even numbers, the answer will be even. So if you multiply two even numbers, I'll make it simple. 6 times 4. That's 24, right? But 4, what is that? 4 is what? Even or odd? Even. And so therefore, this is true. Because this is even. So in that case, it is true. Nice. Let's step up the question a little bit. Alright, so part A, or the next part A. If you subtract an odd number from another odd number, the answer will be odd. Let's check that out. Alright, so if you have an odd number, right, I'll use the number 17. So for part A, let's say you have the odd number 17 and you subtract another odd number, maybe 7. Will the result be odd? No, because 10 is what? That's ending with a 0, which is what? Even. So therefore, this is not true, but this is false. If you add 3 odd numbers together, the answer will be odd. Let's check it out. I'm going to use the simplest odd numbers, 1, 3, and 5. If we add them, what would we get? 9. Is 9 odd? Absolutely. So guess what? This one is true. Part C. All multiples of 2 are even. Tell me. All multiples of 2 even? True or false? Absolutely true. All multiples of 2. Because multiples of 2 are 2, 4, 6, 8, 10, 12. And they all do what? End with 2, 4, 6, 8, or 0. Now it says all multiples of 3 are odd. Is that true or false? List out the multiples of 3. It's what? 3, 6, 9, 12, 15, and so forth. But guess what? Is 6 odd? Nope. Is 12 odd? Nope. So guess what? This is false because it says all multiples of 3 are odd, and that is not true. Alright? And so that takes care of this video. We looked at the types of numbers. So remember, there's composite, there's prime, there is even, and there's odd number. So remember, the only way to get better at math is if you keep on doing what? Practice. Alright, so practice. All the best. Take care.